All right, here we go. I feel like there's a couple things that we should probably revisit just to make sure that everybody's on the same page here with a couple of things. Let's start with recharging plans. Seems to be something that a lot of people are a little confused about. So if you're asked to develop a recharge plan for a battery, I'm trying to think how I want to say this. You have to be pretty specific about certain things, but that goes much wider. When you're talking about aircraft, you have to remember that we're constantly writing things down and making notes and making logbook entries. And you're required to keep notes on what you do. I guess not by law, but just by practicality. So, for example, one of the things that I did a lot of was engine maintenance and overhauls. And so, I know this is electricity, but so I'd get an engine in, and they would often come in, one piece, and then we'd take it apart, and then we would document everything as we take it apart, serial numbers and photographs and stuff, and then I'd have a guy clean it, and then it would move off into inspection and NDT, which is where I took over. And it's not enough. You can't just take a crankshaft or a part and just measure it and go, well, that's good. That's also good. And good and good and good. And I'm going to take it over here and I'm done with the crankshaft because it is good. And then move on to the next part. And then the boss comes along, or, then you get to the point, the boss doesn't, and then I get to the point where it's like, all right, now I got to write a report. I've got to give it to the customer. I've got to detail what we're going to do, what the costs are, what parts are needed. And so I just say, well, your crankshaft's good. Is there a report on it? No, it's good. Well, why do you know it's good? Well, because I said it's good. Was it written down? I just told you it's good. You see how this goes? And so suddenly you're no longer a professional. You're just kind of a jackass. And they're about to throw down $25,000, $30,000 with you, but they're also looking at Tradoplane, which is a publication. They're going, well, I could just go to the factory and get kind of the same engine from the factory for about what you're charging me. So, so you have to instill confidence in yourself and what you're doing. So everything you do is written down. So, the first thing I did is, okay, I took over. I'm like, Microsoft Word now. Make a crankshaft inspection sheet. And so everything was on the crankshaft was noted. Every single journal, every single run out, every single measurement I took. And, then made notations. Was it good, new, serviceable, out of limits? What's the plan? And then it moves into the next phase where it goes into NDT. Then I have an NDT report on that crankshaft, which we did on different colored paper. It's like, yes, it was checked with circular, longitudinal, at this amperage, with this procedure. And the machine was calibrated that day. And there's a logbook for the machine. I mean, it just goes on and on and on, and it never stops. And so I kind of bring all that up to say, if you're not into that, then I don't know if this is the right place for you to be, or you got to find a position where they don't make you do that. And they're out there. I certainly have people working under me who never really did a whole lot. Like the guy who got to take the engines apart and wash them all day. He didn't have to write anything down, so... But so just kind of, throw that out there. I didn't need that up. So circling back around to like the discharge plan or the charge plan, recharge plan. I'm not hoping. I know for a fact that most of you at some point are going to be managers of a shop because you will be because you have it in you. And you have to then realize you will be working with people who don't understand what you're talking about. So it starts this whole thing over again. So, and you have to realize when you hand somebody a battery who you want to trust, you can't just say, take this battery, here's my recharge plan. I want a 1C1 rate on that thing, please. For the most part, they go, I don't know what the hell you're talking about until they're fully trained up. So you have to be specific and you have to say, well, I need you to charge this battery. So let's talk about a NiCad. What would you tell somebody to do to recharge a NiCad battery? Like step one, what would you want them to do? Charge it. Okay. One and done. I like this guy. That's why he's going to be the first manager, and the rest of us are working for him. But no, what's step one? Yeah, you guys have all been studying NiCad batteries. You've been working with them. Make sure it's depleted. Okay, so it just depends on where we're starting from. And you have a good point. It's like, we're starting in the middle? What are we going to do? So we want to talk about, like, from what we know so far, a full service. Okay, so let's, you want to verify the amp hours? What do you want to do?
Yeah, you want to get the rating of the battery.
Of course, we always start with an inspection. That should always be the first thing. So what are we going to inspect for? Same old things. Okay, well, remember that this particular battery is going to look like this. Cookies and whatnot. There we go. So it comes in, and what do you think the first thing you want to do is? Yeah, take the damn lid off. I said take the lid off. All right, we're going to inspect it. What are we going to inspect for?
Cracks.
Well, you kind of said the same thing. I mean, you know, cracks, major corrosion, damage, paint peeling off. You know, it's typical stuff. We're going to take the top off of it. And what do you think you're going to see there?
Hopefully not burn stuff.
Hopefully not. Well, actually, we're in the business of fixing stuff.
Hopefully
Some burnt stuff. Maybe a rat over here that got electrocuted and kind of then decomposed. Often you're going to see a lot of whiteness on these lugs. A little white fuzzy starting to grow. What is that? Normal operation. What is it from?
The water evaporating from the
Yeah, your potassium up there, your bananas and whatnot. Huh? It's the stuffing from the Hydrox cookies got out. So all right, you got corrosion starting to form out there, and that's something that causes resistance, and we don't want all that. So yeah, we're gonna clean it all up. So let's just I'm not sure where we want to start. We could start with just a recharge plan here. So I guess that would assume that it was already discharged, but we moved on to a whole maintenance plan here.
Insulation check.
There's insulation check. I think this would be the point if we're going to do the whole overhaul. We'd have to get the manual out, follow it step by step. And if I were the manager and I handed somebody the battery and I said, I need you to go overhaul and service the battery, I would simply give you a manual and say, like this. It's written, just follow it. Now, I know a lot of people would say, whoa, wait a minute. That's really not how the real world works. They would probably take you with and show you. Yeah, sometimes, if that's the kind of mechanic you are that has to, hold by the hand, let's go. I'll show you how to do it. You teach somebody to do it, and that's fine. But the ones that tend to progress are the ones that can show that, hey, I can read a manual, boss, so let me do it. Otherwise, you get pigeonholed into a spot where, and mind you, I was the manager, so I'm not speaking from like watching. This is how it worked. I was the manager, and the people who could read a manual, I'd say, I need you to go overhaul this battery. Here's the manual. Let me know if you have any questions. And you might look at me and go, that dude I can trust. I mean, he'll probably learn something I don't know and tell me something I don't know in that damn manual. And then you'd have other people who needed to be shown everything once, twice, 3 times. Well, you just give them the easier jobs because you don't have time to show them because you're pretty busy. So you show them the menial tasks. This is how you grease wheel bearings. Now I've showed you. Now you just do the wheel bearing. You're my wheel bearing guy forever now. So anyway, if you're going to do the whole thing, read the manual. But where I was really going with this was more of a recharge plan, because I know that you guys know recharging at this point, or at least most of you have worked with it in this project. So we can go back to recharge plan, or we can take a step back and we can say, instead of inspect, we'll say, I want to know what is the amp hour capacity of this battery as it came in, and then I want to recharge. I want a full recharge, and it's going out. You need to do those 2 things. Obviously, you would fix anything that's wrong, but let's just start there. So how are we going to figure out the capacity of the battery? It's NiCad.
Measure discharge.
Measure discharge. How else can we do it?
cells.
Can't count the cells. There's 20 of them.
Look up the part number.
Look up the part number. I see where you're going with it. You want not the book capacity. What is the current capacity of the battery as it came in? Or I could say the percent amp hour capacity the battery is as it showed up in the shop. How's that? Now I'm being a little more specific. So for those of you who said count the cells, read the what I wrote. But now I want to know what the amp hour capacity is, or the state of charge. What is the state of charge as the battery just showed up on the shop floor? Because the person who just dropped it off said it was fully charged. It just came out of the aircraft. The aircraft finished a flight across country, so it should be fully charged. And but it's time for some maintenance, so we want to do we want to check the percent capacity, and then we're going to do a recharge. So those are two things. So number one, we need to figure out the percent of its full amp hour capacity. So how do we do that? Who said measure discharge? What else?
Would you be able to do like an open circuit voltage divided by closed circuit voltage?
Never.
Never?
Thank you for saying that. Never, because, and this is why I'm doing this, the voltage of a NiCad does this
Oh yeah, that's right.
until it does that. So it could be that far away from completely dead and it's going to look perfect.
Mm-hmm.
So we can't do that.
Is there a log with it? Because you said sometimes that
A log?
NiCad batteries will have a.
Oh, sure, there's a logbook you look through. Hey, look at that. It's been 500 hours since it was back in our shop. We did a capacity check, changed a couple cells, did this, that, 500 hours ago. All right. So, yeah.
Can you, what else would lead acid do a hydrometer test?
Hydrometer test. So, thank you. Hydrometer for lead acid. As the lead acid dies off, the acid becomes more
Water-like.
water-like, and as it charges up, becomes more
Yeah.
acidic. A NiCad battery, as it dies off, the electrolyte stays the same, and as it gets charged, it stays the same, but the level goes up and down. So, okay, so we can't, what was the first thing? We can't do a voltage check. We can't do a hydrometer test on it. So far, the only thing I've heard is measure discharge. What else?
Check the fluid level and you mentioned that. So
We could check the fluid level, but the problem with that is, what if over this last 500 hours, there's been a lot of starts, stops, it gassed quite a bit, and so they're all kind of low.
Oh, as you're charging it, can you check how much amperage it's pulling?
No, because I love this. So we can't do that because we'd only be able to do the water level if we knew the water level to start with and then saw it go down. But it's an unknown, so we can't do that. Your idea was pretty good. What was that one?
Yeah,
When you're charging,
open.
when you're charging it,
Charging it.
how much amperage?
How much amp it draws? Okay. Problem with that is a lead acid battery wants to be charged using
Amps.
volts. A NiCad
What's constant amperage?
does not like that. So we're only going to use constant current. And the amount of current that goes in it is going to be strictly dependent upon what I turn the dial to.
So it's the other way around. How much?
How much voltage?
How much voltage?
No, because to a little bit of an extent. If it hits 1.5, then it's probably charged, or it could be low on water. So we can check the water level, add some water. But no, not really, because that didn't tell me, was it fully charged, half charged, all the way charged? Somehow
There's too many things I can.
it just doesn't tell you. Just doesn't tell you. It's going to range between 1.3 something and 1.5 something. It's such a narrow little range, so no, not going to work. All right. Yes.
I know it's not like doing the measuring the state of discharge, but like putting a load on it and measuring it.
Okay, like the open circuit versus
Yeah.
closed circuit. NiCads don't work that way. They just don't. Open circuit, closed circuit's going to stay pretty much the same until it's dead.
Yeah.
All right, we're running out of ideas here. Anything else? These are all great ideas. You guys are really bringing it. This is what I wanted to do. Everybody's afraid now. We done? No other ideas?
Ask the boss.
Electrolyte?
Okay. So we're back to which one worked?
Measured discharge.
Measured discharge. So it's the only thing we got?
Yes.
It's the only thing we got. So the only way to know if a NiCad is charged is to
Discharge.
completely discharge it, and then we can say it was charged. That's it. Done. No other way. Completely discharge it, go, that was charged. You wanted to know? It was charged. Now I tell you. That's it. No other.
That's 12 hours in your paycheck that the
We-
customer didn't
you don't
necessarily do.
normally watch it the whole 12 hours. You usually make yourself useful. Okay, so we're to discharge it. Now, the thing about a machine that discharges it, and these machines for doing NiCads can get pretty complicated and expensive, but you tell it exactly how many amps and exactly how much, and then you can just measure the time. So I can dial the machine, like for your example with the little cell right there, or let's just say we had something that's 40 amp hours, right? So I could tell the machine, hey, I want you to take a draw of 40 amps, and it should be done in, if it's fully charged, in 1 hour, right? Or I could say, take a draw of 20 amps, and it should be done in
2 hours.
2 hours. Or I can turn the whole thing around. Oh, no, it's the same thing. So let's just take it over to you're doing one little cell. That little cell is,
1.2.
your cell is 1.2 volts. What's the amp hour rating on the cell that we're handing out? 2 amp. Close. It's got it. No? The one I'm handing out in class.
Oh,
24.
That's right. It's 24 amp hours. And let's see, this is going to go into a battery box, and the battery box is going to have 20 of these things. So how many amp hours would I get out of that? Does it work that way? They're in series. So they're, I don't know, I just wonder if they want to notice. You noticed. So how many amp hours is that?
440.
Wow, does that sound right? So I got a cell, I got a cell, I got a cell, and so they're wired like this. So they are in series. And what happens to amps in series?
Stays the same.
Stays the same. So this battery went in, there's 20 cells, so the amp hours is
24.
about 24 amp hours. All right. But each one of them is 1.2 volts, and there's 20 of them, so the voltage would be about 25.2 volts because the voltages all add up. So we got one cell though at 24 amp hours, 24 amp hours, and your task is to discharge it. Well, unfortunately, you don't get the luxury of having a machine where you can just dial it to a set thing and say it will be done in exactly 1 hour, 2 hours, an hour 30. You just get something and you get what you get. And so if it happens to be probably shouldn't do a hard number, but 3.5 amps. And that's just what it is. How are you going to determine what the capacity of that battery is or the state of charge is?
Time it until it reaches 1 volt.
Say it again.
Time it until it reaches 1 volt.
You simply time it until it gets to what? Why 1 volt? That's its dead point. Who says? The book said. The manual said, when it gets to 1 volt, it's dead. You're done. Right? So you just, and let's just say it took you 3.5 hours. Well, how many amp hours did you get out of it? Huh? Didn't know there was going to be maths today.
12.25.
He says 12.25 amp hours. If we were drawing 3.5 amps for 1 hour, what would be my amp hours? 3.5 amp hours. If I had 3.5 amps for 2 hours, I would have 7 amp hours. If I had 3.5 for 3 hours, I would have, what's that?
10.5.
Thank you for doing it. 10.5 amp hours. If I had 3.3 amps for 3.5 hours, I would have 12.25. Do you see where I got that from? It's kind of a multiplication. How many amps times how many hours equals amp hours. That's how they get that. Is everybody with me on this so far? Okay. So that's the discharge. So we're going to discharge it. We get 25.25 amp hours. Now, if I did happen to get 25.25 amp hours, and I was supposed to get 24 amp hours, yeah.
So does this mean that you have to fully drain it, charge it up, and then do the measured discharge?
No, my question was, what was it when it came in my thing. But yes, if you are doing a full-blown measured discharge test on the battery, you have to start at a known quantity. So yes, you guys do that. You guys, yep. So I'm going to show you how you do this in a second. So if it's supposed to be 24, but we only got 12.25, that's barely over what, 50%? So you just do some math, so you can find out that's 50%, a little over 50%. All right, but if we wanted to know, we want to do this correctly, you bring the battery in and you just put it on the machine and you just do a discharge. Don't care how long it takes, just do the frickin' discharge. You got to get it down to 0. You get it down to as close to 0 as you can, and then you put those on it. 16 hours overnight. These are the they're not resistors, they're just stainless steel, pieces of stainless steel, and you just stick them in there and they get really freaking hot. I think that's why they look that color, because they got blue. And once you put them on, you don't want to touch them because they're going to get really hot, and you leave them the heck alone, and they start stinking, and you get that battery, leave it on 16 hours. So yeah, I don't remember anymore, but I'm sure you're right. I knew it was overnight, and you get that battery dead because it's shorted out overnight. This is grounding strap, so you just shorten it out. So short it out.
We usually start hooking them up like that 2, 3 o'clock in the afternoon, and tug down until whoever's working on the battery is back in the morning at 8.
Yeah, I seem to remember that we were watching the discharge. You were watching the voltage of each cell independently. And when it got down to, it was like a 1/4 volt or something?
Something like
Yeah, then you stuck the strap on. And then you just waited till the next one got, so it's not like you stuck them all at once. We were doing it like individually. So yeah, so then you're going to leave it on there all damn night. And guess what the voltage is when you come in the morning? Oh, it's 0. It's full on 0. And then you could take it apart and clean off all of the, we take off all the straps, clean all the connectors. You can take the cells out, clean the battery box, you put it all back together. And now we're going to do a recharge. All right, so recharge. And the book is going to give you some options, right? So we're going to continue working with 24 amp hours. And if you remember the book, it tells me I could do a 1C rate,
1C rate,
a 0.5 C rate, or a 0.1 C rate. Now, you can't just tell somebody who doesn't understand something, and this is where I want you to convey back, so I know that you know, what you're talking about. Don't say, I'm going to charge it for a 1C rate, because that doesn't convey that you understood the information. It conveys that you just read the book and spit out what you read in the book. So we're always looking for, do you understand it? Because if you don't, then we want to make sure you do, because you're going to have a pretty big test coming up, right? And this is your chosen profession. That's how you want to make money. And the better you are at what you do, the more money you make. I don't know. Maybe I should just do. Is anybody who doesn't care how much money they make, and you just we can go easy on you? Yeah. Wait, you guys are good at money for this. So what will I set? So this is the rate right here, rate. And this is going to be the amps. And this is going to be the time for this battery. So how many amps, if I do the 1C rate, how many amps will I do this for? 24, because that's 24 amp battery. What if it's not? What's the one that I gave you a certain part number? How many amps was that one? 43 amp hours. Well, that's totally different. So don't tell me 24, because 24 would be wrong, right? That number there would be? If it was be 43. So we do 43 amps for how long? 1 hour. Okay. And then we go into the top charge, right? Which I think is 0.1 for 4 hours. Okay, so it's the same for all of them, though, right?
Yes.
Yeah. Man, some of you guys are so sharp. So top charge. So top. They call it overcharge in the book, right?
Mm-hmm.
Yeah, we call it top charge. Top charge is 0.1, so that's going to equal 2.4 amps, and for 4 hours, for 4 hours, and that's the same all the way down. Okay, but if I said, hey, I'm going to choose the 0.5 C rate, how many amps is that? 12 amps. It's half of the C rate, so 12 amps. So how long is that going to take? 2 hours. Or I could choose the 0.1, which is 2.4. This is one Tyler does because he sits there and watches it. And how long are we going to charge it for? 10 hours. 10 hours. All right, so that's doing a recharge plan. You just pick one of those and say, hey, Kev, this is the one I want to do right there. And it doesn't matter if I like it. It's not my choice. It's what the book says. So it's right. Right is right. Now, just so you know, you can't just put it on the charger and say, well, I'm going to, pick the 1C rate, whatever rate, and put it on the charger, and then I'm going to walk away from it. Obviously, you have to pull off the little straps or they get really blue. But when you start charging it, you have to have a voltmeter and constantly monitor it. So as you already know, what's the first thing I'm going to look for? What's that? 1.5 jump. So the the voltage that is going to be putting out is going to be around 1.4-ish about. So you're going to measure anywhere from, 1.2 to 1.3 something, 1.4 something, depending on the state of charge. But if it's suddenly, it was dead a second ago, and I started it, and I put the voltmeter on, I'm like, okay, 1.25, 1.2, 1 something, 1.3, 1.55. Got an outlier.
Stop.
What's wrong with that one? It's low on water. It's going funky on us. It's taking a lot of voltage right there. So we got to stop, got to add some water, because that's what the book says. How much water? 5 cc's. Remember the book. All right. But then the other thing, and I'm pretty sure the book should talk about this, these cells will reverse. So you have to check each one, and you're constantly going like this because they're in there. But you want to make sure the positive's the positive, the negative's the negative. Positive's positive, negative's negative. You get to 1, it's like, well, wait a minute. I've got the positive on the positive, the negative on the negative, and the meter showing negative some volt. It'll do that. It will reverse its polarity inside of that one particular cell will reverse polarity. I haven't seen it a lot. Do you guys see that? I'm not sure.
It's always something you watch out for. I'm not sure how often you see it.
I don't remember. I think one did it once. Just pull the cell, put a new cell in. Or
I was going to say, what is the fix for that? Just replace that cell completely?
we usually had extra cells. You got a Sharpie, don't you? You can just scribble out the plus and put a minus. It's not rocket science here, right?
It just doesn't seem like a great idea.
No. Replace the cell or take it all the way back to 0. Try it again. But I think I'd replace the cell and do that one outside of the box. So, all right. So then we are charging, and we're doing whatever we're choosing, so it doesn't matter which one we've chosen. But we're going to monitor it. Okay, how long are we going to charge it for?
1 hour.
How do we know when it's done?
1 hour.
And that's when it's done, because that's what the book says. It doesn't say charge it until the voltage is this or the amp set. It says charge it for 1 hour, 2 hours. That's what it tells you to do. So you set the clock. That's why there's a clock on that machine. It automatically shuts off exactly at the right time. So we have that there, the brown one that was in there today. That's 24 amp hour. Probably should have, because it was not fully discharged, but I did a 20 amps at 1 hour. So just kind of made up my own thing, just so we can get some batteries out there. But there's time. So, but the book talks about a final voltage that you should be checking for. And what's that voltage?
1.5.
Okay, it's written in 1.5. I think it's 1.5, 1.55. So if you have 1.5. But what is the open circuit voltage of a NiCad cell? So if it's 1.2 volts is the actual voltage of the cell, how the hell am I getting 1.5 out of this thing? It's connected to the charger. So when it talks about 1.5 or 1.55, it's while it's charging. You're checking it at the end. Got it? So at the end. So now I take it off the charger, and I'm like, all right, what should the voltage be? No, you're wrong. It's going to be close to 1.5. What? It will for a couple minutes. So it's gonna calm down. So, but the point I'm making is the 1.5 is under a charger. And then when you remove the charger, it'll come down a little bit, high 1.4s, and then wait a little while, and it's going to come back to its 1.2, 1.3-ish area. So.
Does that voltage come up immediately when you start charging, or?
Oh yeah.
So it's,
Not to 1.55.
okay.
If it does, you have a problem. So immediately, it could go from 0 volts to 1.2, 1.3
So what would I expect to see after 5 minutes?
while it's on the charger.
Yes.
About 1.2, 1.3.
So it does rise.
Immediately, because the charger's putting voltage through the system to get the amperage in. If you see 1.5 immediately, you got a problem. The problem is cell is low on water. Yeah.
Does it sort of like follow the discharge graph in reverse when you're charging it? So like the voltage will jump up right away and then just
Yeah, kind of does. Yeah, that's what I've noticed.
Is there any advantage to other than time between these C rates, charging the different C rates?
You know, I would want the book to say something about this. It doesn't. So now we're into my opinion, and that's all it is. Is that if it were my battery, I feel that the higher the C rate, the more heat it's taking, and the more heat that it's taking, the more abuse it's taking. So I feel that the 0.1 would be a very lengthy and slow process, but it would keep the battery cool and hopefully last longer. My opinion.
I can trip.
Yeah.
Can you just kind of refresh my memory, maybe a little touch up on you said when you check the voltage of an individual cell, you get one that immediately volts at 1.5 when the issue is it's low on water. Why was that again?
Why is it low on water?
Why does immediately high voltage indicate low water?
I would have to say that more voltage means that, because the amps are the same, so if one has a higher voltage drop, it means that the resistance is higher. If the resistance is higher, there's a problem, and the problem happens to be low on water. Best I can do.
And that's just because like the plates are actually not submerged beneath the water.
Sounds like a good idea. Yeah, I like that. Yeah, I like that one.
So it's kind of the same.
I don't know all
Kinda
things
like-
NiCad, so some of this I gotta kind
so
of
like
guess.
it's kind of keeping it like
Cool.
It's a cooling effect to the plate itself.
Cool, or it keeps the resistance where it should be.
Yeah.
All right.
More volts, more better.
More volts, more bigger. I was trying to remember what. There's a number, because I've got it written down here. It's 1C. And I want to say it can go the other way. I guess that'd just be a 2C. That's what just stuck in my head. You can go 2C rate. The book doesn't tell you to, but I wouldn't. But what would be the 2C rate?
48.
48 amps for half hour. Yep. Get her done.
Oh, you need 96.
More power.
Do it in 15 minutes.
Okay, so yeah.
That'd actually be a good question. Like, what would happen if you actually do like 3 times the amount of amperes? Like, what would actually happen?
I think you could start warping cells. You'd blow out the cellophane, then you get that thermal runaway.
Mm. And then you just evacuate the building.
Yeah.
Yeah. Okay.
Got to bury it in sand or something.
Make glass.
Okay. Everybody's feel good about that?
Yes.
Any questions?
One question.
Yeah.
When checking, we were talking
I'm sorry.
about
Could you submit your questions in writing? No, just go ahead.
when checking the, and we get an outlier, that 1.5 jump.
Yep.
Is that before the 1 hour on the?
Oh yeah, it's immediately.
Okay.
Like connect the charger,
And then start checking the
go
cell.
pick up the voltmeter, and start checking the cells.
Okay.
So I would check it immediately, and then I would check them again in another 5 minutes.
Got it.
And then after that, I wouldn't be so concerned about the water thing, but then I'd be watching for reversal. So
Okay.
we checked them like every 5 minutes for the first half hour or something.
And then obviously check them again once the hour's
How
up.
often you guys do it?
15 usually.
Every 15 minutes?
Yeah.
Yeah. And after that,
All of our spec sheets for going through all the cells have 15 minutes.
every 15 minutes? Yeah, we always checked them like, I don't know, I'm just kind of weird that way. I never trust stuff. So I always checked them a lot during the first few minutes. You know, kind of get done and start again. So I have every minute for the first few. Yeah, you get paid by the hour, right? So does it hurt to check it too many times? Not a thing. Because it takes a whole lot of attaboys to make up for one aw shit. So, all right.
I don't like that they just reverse though. Like that's messed up.
Isn't it though?
Like,
It's
oh, it's just one way. One way.
hey, remember how they used to be positive over here and this is negative? Yeah, let's do it the other way around. That'd be fun.
Why did they do that? Oh.
How would you decide
What's it?
reverse cell while you're charging?
What's that?
How
What?
do you detect a reverse cell while you're charging?
How do you detect it?
Yeah.
It's funny. You literally see it on the voltmeter. It just you got
So
one's
if
going
it's
backwards.
Shoving the current backwards, but it's like the voltage is still.
Beats the hell out of me how it works. I know you wouldn't think that it would work that way, but you do tend to get it that way. So yeah, one is backwards. It's like, how do you do that? Well, I guess if you took one and you literally put it in backwards, you'd notice it when you checked it. So same thing. Yeah.
Maybe because there's a short inside the cell.
I don't know if that would cause it to go backwards. Could. Yeah. Yeah. I know. Yeah. Could. I don't know. We'll say maybe. All right. What else? Because I don't want to see you guys suffer and be frustrated in class, but at the same time, there is this theory that holds true, and I'm going to stick with it. If I just tell it to you, you'll remember it for a few minutes, as evidenced by the fact of the number of stuffs that I tell you in here, and you don't remember it over there. But if I let you struggle through it and think through it, you really create that synapses, that new wrinkle in your brain, and it really cements it in there. So for some of you, well, I don't mean to go that far with it, but
Just wake up in the middle of the night.
yeah, I don't know. Sherman.
So, if you don't tell us anything, definitely remember.
He's got a good point.
No, listen to him.
You guys clock out at 9:20 if you don't mind. I'm done. Ah, they tell it to you, and then you forget. And I'm like, well, you kind of know it. Now you just got to search for it, bring it out. And when you search for it, bring it out. You know? I mean, you guys know Ohm's law, right?
What we do is
I told you 2 hours ago I did.
He's like, well, give me this.
So you know Ohm's law, yeah? mean, right? So, you know, I got a battery,
Did about 2 seconds ago.
you know, and you got an ammeter in the system, and you got some sort of resistor. And the ammeter says you got 5 amps on it. And I said, hey, by the way, what's the resistance of that? Well, I don't know. EIR. What do you know? You know you got 5 amps. Well, now what would you do?
We got 1.2 volts.
Okay, you got EIR here, you got 1.2 volts. Here's the problem though. You got a wire right here, right? Well, that wire definitely has some resistance when you start getting to 6 amps. You got a wire over here. That wire's got some resistance. And you got another wire here. Some of you have a couple of wires over here. I don't know why, but you got a couple of wires. So suddenly you've got R1, R2, R3, R4, R5. You don't know anything about those things. So what is this 1.2 going to help with?
Measure the voltage drop.
If you know 2 things, the third is obvious. So what could you do to figure out the amperage of this mess?
Current is constant.
Get your voltage from the source.
All the way around.
Well, you know your current is 5 amps.
And I want to know this.
Voltage drop across the resistance.
Now, this might surprise you, but once upon a time, you had such a project that looked like this. I drew it back. Yeah, that's right. With a little, yeah.
Yeah.
And I said, oh, hey, by the way, what's the resistance of that LED? And what did you do to find the resistance of the LED?
Find everything.
So EIR. And I said, what is the resistance? What did you do to find that resistance?
Voltage drop and current.
You did a voltage drop. You measured the voltage. And then you took it apart and you measured the current. Did you ever measure the resistance?
No.
Okay. So I say on this one, what is the resistance? And you can't take it apart. And the reason why you can't measure the resistance of that resistor is because it's very small, 0.18. It's very kind of difficult to read. You start getting these little resistances because your ammeter or ohmmeter kind of lies a little bit. So ammeter says 5 amps. Now what am I going to do?
Isn't the voltage drop of an ammeter 0.255 volts? Would that help or anything?
You don't know that for a fact. And it turns out to be not true.
All right.
So I've proven it over and over and over. You guys do these, you know, you read the book, you do it correctly, you're writing down the voltage drop, you're doing it, and then we get to there, and it doesn't math out.
Yeah, in the book it says approximate.
Yeah. And so I haven't done it with a lot of you, but some of you I've actually said, especially probably David and Tom, I think, the first guys who did it, said, what's the resistance of this ammeter? Who did I do that with?
Me.
Was it even close?
Nope.
Not even
Voltage
close.
drop is like half volt, I think.
Yeah, it's completely off. So you can't do that. I don't know. Maybe they don't account for the leads. I can't answer why it's off so much. But you have the leads. Then every time you have an alligator clamp that's touching something, there's resistance between that clamp, which you don't know. So there's resistance there. There's resistance in the wire, then the meter, which is approximate, then another wire, then another clamp, and then you go to the resistor. Then you got a clamp coming off the resistor with probably another clamp, and so you don't know. So back to this. How am I going to figure out the resistance? Measure the voltage drop across the resistor.
With the digital multimeter that's way off to the right.
With a voltage meter that's way off to the right. It's not going to be a lot, so that's why I like to use the digital. So you get some sort of voltage drop over there. I don't know. Let's just say it's 0.56 volts is your voltage drop. What does that make the resistance? Well, if I've never mentioned it before, shame on me, but there's this formula where it's E, I, and R. And if I want to know R, it's E, 0.56, divided by 5 equals
0.112.
112 ohms. Now, if that's 0.112 ohms, when does that change?
Never.
Say it again.
Never.
So it's always the same?
Yeah.
It's always the same. So if that's always the same, I can then take out the ammeter and I could say, now what is the current flow? And you would say, I don't know. Let me measure the battery and then I'll do, oh man. You come back in 30 minutes, Kevin? So what do we know?
Resistance.
That doesn't change. Still in series?
Yeah.
As long as you keep a series circuit, it's not 5 amps. Because now I want to know what the amperage is. So how are we going to find the amperage? Measure the voltage drop, right? You get some voltage drop, and now it's 0.7. So the current flow is 6.25 amps. Whoever said amps, you're not wrong. All right, so then I take another wire and I go like this. What kind of circuit do I have here?
Series parallel.
It's a series parallel. I have 2 resistors in parallel coming back. You said series parallel. What's the part that's still series?
That resistor.
So if I said now what is the current flow, it is what has not changed.
Resistance.
So EIR, what is still the same? 0.112. So what do you need to do?
Find the voltage drop.
Find the voltage drop. Oh, and it's probably like 0.8 now. So now the current flow is it's 0.8112. That's what it is. Correct. He's not wrong.
7.14.
7.14. Yeah, if you say so. Okay, 7.14. Why did the current go up?
Added in more paths.
Because the
Ki-
resistance of parallel is smaller than the resistance of the lowest.
I added more paths.
Yeah.
Somebody today said you added another wire, so that's the same thing as making that one wire bigger and a bigger wire. Who said that? Because that was actually pretty good. Mike, yeah, good job, Mike. See? So that's why I always like to give you the answer. I look for the answers that you guys give sometimes. They're really cool. And I thought that was a cool answer. He said, so it's like a bigger cross-sectional area. Bigger cross-sectional area carries more current. I'm like, I like that. And what I always said is you have 2 resistors now in parallel, which means that the total resistance is less than the smallest resistor. So resistance went down. So current went up. Okay. Is there anything anybody's having trouble with in lab? You're like, other than trying to figure out what's wrong with your motor circuit.
That's fine.
That it is. Now wait. In all fairness, he was given a bad wire. So he troubleshot his circuit forever, and there was one bad wire in the group. So not intentional. Okay.
We said that lead-acid battery prefers to be charged with a constant voltage.
Yes.
Why then does the field manual recommend an initial charge with a constant current?
They recommend a constant initial charge under a constant current and on a recondition after a failed capacity check. I don't know why. The only thing that I can come up with in my own mind is that they want an exact amp hours put back in. And the only way you can exactly charge a battery to a very specific amp hour rating is if you can control the amps. Otherwise, you're controlling the voltage and the amps are all over the place. That's the only thing I got. But I do tell you, man, my battery, I was like, what the hell? I mean, it's like super battery now. I'm kind of worried about why the second time through when I tried to discharge it, that thing was going to look like it was going to go all damn day. So, happy with that. you know, because the dishwasher broke. So the money I didn't spend on a battery, I now get to spend on a dishwasher. But I guess it's better than buying a dishwasher and a battery. Anything else? Oh, break time. Okay.